In this video, we're going to discuss points of inflection. First, let's distinguish what is concave up and what is concave down. Well, a function is concave up if the graph is curved with the opening upwards, as in A. A function is concave down if the graph is concaved with the opening downwards, as in B. Now, if we look at this function y equals f of x, it's been split up into three distinct parts. The first part is concave up, the second part concave down, and the third part is again concave up. Where the concavity changes from concave up to concave down, here, and where it changes from concave down back to concave up, both of those are points of inflection. So in order for there to be a point of inflection, the concavity must either change from concave up to concave down, or from concave down to concave up. Let's go through some questions. Which of the labeled points on the graph are inflection points? Remember, for there to be an inflection point, there must be a change in concavity. So if we look at point B and G, so B and G, you can clearly say that there are changes in concavity, so therefore inflection points. There are 2 points that look like they are points of inflection, and they are D and E. But at D and E, they're both concave down both sides of those points, so therefore not inflection points. Question 2. Find any points of inflection for the curve with the equation y equals e to the x brackets 2x squared plus 5x plus 4. In your answer, give coordinates accurate to 3 decimal places. The first thing we have to do is find the first derivative, but this is a product, so we're going to have to use the product rule. So let u equal e to the x. So u dash is equal to e to the x. Let v equal 2x squared plus 5x plus 4. So v dash is equal to 4x plus 5. Now we can cross multiply. So we're going to get dy over dx is equal to e to the x brackets 4x plus 5 plus e to the x brackets 2x squared plus 5x plus 4. We can bring that together, so we finally get y dy over dx is equal to e to the x 2x squared plus 9x plus 9. The second thing we have to do is find the second derivative, but again it's a product, so we'll have to use the product rule. So we'll let u equal e to the x. So u dash is equal to e to the x. V is equal to 2x squared plus 9x plus 9. So v dash is equal to 4x plus 9. So now we can find the second derivative, d2y over dx squared, cross multiply, so we get e to the x times 4x plus 9 plus e to the x times 2x squared plus 9x plus 9. Now we can bring them together to get d2y over dx squared is equal to e to the x brackets 2x squared plus 13x plus 18. The next thing we have to do is put the second derivative equal to 0. So therefore we get e to the x 2x squared plus 13x plus 18 equals to 0. Therefore e to the x equals 0, or 2x squared plus 13x plus 18 equals 0, but e to the x cannot equal 0, so therefore 2x squared plus 13x plus 18 equals 0. So if we factorize, we will get 2x plus 9, x plus 2 equals 0. Therefore, x equals minus 4.5, or x equals minus 2. This tells us we've got 2 points of inflection. One at when x is minus 4.5 and one at when x equals minus 2. So we're going to have to test for concavity either side of these points. So the first thing, we're going to second derivative when x equals minus 4.5. This will give us e to the minus 5 brackets 2 times minus 5 squared plus 13 times minus 5 plus 18, giving us 3 e to the minus 5, which is definitely greater than 0. Now we'll do d2y over dx squared for x equals minus 3. This will give us e to the minus 3 brackets 2 times minus 3 squared plus 13 times minus 3 plus 18, which equals minus 3 e to the minus 3, which is definitely less than 0. Now we'll do the other side of minus 2. We've got d2y to dx squared for when x equals 0. This will give us e to the 0 brackets 2 times 0 squared plus 13 times 0 plus 18, which gives us 18, which is definitely greater than 0. Therefore, both x equals minus 4.5 and x equals minus 2 are points of inflection, because concavity changes. The last thing we have to do is find the actual coordinates of the points of inflection, and I'm going to do this on the TI Inspire. If I open the TI Inspire at a calculator page, I'm now going to define my function, so I'm going to call it g of x, control button next to the 9 to get my colon and equals. Now I can type in my function e to the power of x brackets 2x squared plus 5x plus 4. Hit enter, so it's now been defined. Now I want to calculate g of negative 4.5, enter, and g of negative 2, enter, and there we have our 2 points of inflection, and they are at minus 4.5, 0.244, and minus 2, 0.271 to 3 decimal places. So let's write down our points of inflection. Points of inflection are minus 4.5, 0.244, and minus 2, 0.271.